Hello and welcome to the Avalanche episode of the International Society of Explosive Engineers web series, Explosives Every Day. My name is Alistair Torrance and I'm the current president of the International Society of Explosive Engineers. Our organisation started in 1974 when a group of like-minded people got together in Pittsburgh, Pennsylvania to discuss how to better apply commercial explosives and how to champion the blaster in the field. Move forward to today and we're an international organisation with more than 4,000 members spread over 90 countries with a mission to advance the science and art of explosive engineering worldwide. We do this through sharing our knowledge and providing training and education for everyone involved with blasting. We also have a strong education foundation and have awarded more than $1 million in scholarships to our students in our industry. Before we get started, I'd like to thank our series partners, Dyno Nobel, OPIT Blast and LDE Global. This series would not have been possible without their tremendous support. This episode highlights how explosives are used in avalanche control. It's been sponsored by Austin Powder, and here are a few words from them.
Austin Powder is a leader in the manufacturing, distribution, and application of industrial explosives. Founded in 1833, today the company provides a broad range of highly engineered solutions. From bulk trucks to Red Devil underground units, emulsion technology to E-Star detonators, predictive vibration modeling software to optimize blast design. All Austin Powder solutions are developed to advance the safety, reliability, and efficiency of breaking rock.
I'd like to introduce you to the presenters of this segment. They're Brian Gorsage, of the Colorado Department of Transportation Avalanche Coordinator, and Mark Ganster from Austin Powder in Europe. So Brian Gorsage is a statewide avalanche coordinator for the Colorado Department of Transportation. He's had 17 years experience in forecasting and controlling avalanches throughout the Intermountain West. Mark Ganster is Manager of Blasting Technology for Europe for Austin Powder. He's had 16 years working at Austin Powder International and working in areas of avalanche control. And now Brian and Mark will discuss the history of avalanche control, the various tools they use, and how they help offset the risks of avalanches in high country. It's going to be a question and answer session with the presenters right after this presentations. The panel will discuss many questions that were asked by a live audience at the time of this episode's first airing. Okay, well let's sit down and relax and see how we use explosives to control the risk of avalanches.
Hi, my name is Brian Gorsage, and I am the State Avalanche Coordinator for the Colorado Department of Transportation. My day-to-day activities include avalanche operations, protocols and SOPs, CDOT Avalanche Training Program. I'm the Program Manager for the Artillery Program, of which we have 7 artillery pieces located throughout the state, and that includes howitzer maintenance and the purchasing of ammunition. So handle the statewide explosives programs, permits with the Division of Oil and Public Safety, RACS maintenance, and the CIAC contract. I started out in this industry by ski patrolling. I got my first job at Snowbird in Little Cottonwood Canyon, which is a unique and avalanche environment. That canyon receives over 550 inches of snowfall a year, and avalanche mitigation via explosive use, howitzers, and avalanchers is conducted on a nearly daily basis. Back in World War II, the 10th Mountain Division was in the European Alps fighting the war, and they were using explosives and avalanches explosives and howitzers to trigger avalanches to take out larger groups of the opposing side. So they weren't trying to mitigate avalanches. Those guys, when they came, the 10th Mountain Division, when they came back to the United States after the war, a lot of those guys had a lot to do with the startups of ski resorts throughout the West. And those resorts that needed avalanche mitigation, they were able to bring that experience home and do that to keep ski runs open, and then trending towards, well, we need to keep the highways open to get people to the ski resorts. And so they brought those skills back from World War II. The CDOT Avalanche Safety Program, our mission, to reduce the risk of avalanches to people and property on Colorado's state and federal highways. This risk reduction is accomplished with avalanche forecasting and our explosives and control program. We do this in partnership with the Colorado Avalanche Information Center. Throughout the state of Colorado, we have 400 documented avalanche paths impacting Colorado highways. 180 of them receive regular mitigation. We have 8 CIAC forecasters that are located throughout the state. Based on weather conditions and snowpack factors, they will make the recommendation to CDOT to close and do avalanche mitigations with explosives. CDOT licenses 70 mitigation personnel with Type 1 licenses that are trained to a very specific standard in the use of explosives. CDOT has a big toolbox of avalanche mitigation tools. The gold standard in the United States since the late 1940s has been the howitzer. There have been several variations of recoilless rifles, but today we are using the 105 millimeter howitzer. It is leased to us from the Army. It delivers an 8-pound explosive payload to trigger the avalanches. It has a 7-mile range, although we do not use it to its full capabilities with the range. Another tool that we utilize is the Avalancher. It was developed in the early 1960s and has been used for mitigation in avalanche terrain ever since. It's a compressed nitrogen delivery system that delivers a 2-pound explosive payload. They are commercially available, and CDOT currently owns 10. Helicopter bombing is a great way to deliver large explosives to the tune of 25 to 50 pounds explosive payload into many starting zones covering large geographic areas. The disadvantage of the helicopter is you have to wait until the storm clears. You need good visibility and relatively calm winds. So the GAZX, this is one of the first RACS remote avalanche control systems that we have that I will discuss. And this is in conjunction with reducing our dependency on projectile-based systems. The GAZX system has been in the United States since the early 1990s, but has just recently, with the Army's guidance, picked up a lot of steam as teams across the United States are installing these. It uses a mixture of propane and oxygen to trigger a detonation above the snowpack, triggering the avalanche. It has a central gas shelter where the oxygen and propane live. It is delivered to the exploder. It is also remotely operated via a radio and a laptop. So it is very efficient, does not require as much manpower as our other tools, and the air blast is very effective. The Obelix is produced by the same manufacturer as GAZX and works relatively the same. It uses a mixture of hydrogen and oxygen. It is also remotely operated via laptop and radio, and is a self-contained unit. All the gas electronics are located inside that gray plastic shell. It is deployed and retrieved via a helicopter. There is a tower mounted in the starting zone permanently, and each fall the unit is deployed out onto that tower, and in the late spring, early summer is retrieved off of that tower and put into storage for the summer for maintenance and gas resupply. Other RACS projects that we have just recently installed in the fall of 2020 is the VESON Avalanche Tower. It is also remotely operated via a tablet and a cellular signal. When connected to, we can deploy a 4-kilogram charge that hangs from a string, giving us the air blast. We installed 5 of these in southern Colorado this summer and are excited to use them in our program. Also this summer, we installed 2 Avalanche Guard towers. This is also remotely operated and it works via a tablet and a cellular signal. The Avalanche Guard delivers a 4-kilogram charge out into the starting zone. It is propelled by a black powder. So one of the disadvantages to these projectile-based systems is we had to wait for daylight and reasonable visibility. The racks give us the ability to do this work in any weather condition at any time of the day. So we had to apply for a variance to do the work at night with our oversight, which is the Division of Oil and Public Safety. So we purchased these thermal imaging goggles that we are now able to clear the starting zones as a part of our normal safety protocols with road closure and sweep. One of the cool things about these thermal imaging units is not only do we clear the starting zone, but we were able to see avalanches in a new way. So in the upper left is a GasX exploder, middle right is a GasX exploder, which is just about to detonate. Central gas shelter's up on the ridgeline. It is detonated, has triggered a large slab avalanche. This avalanche is going to pick up a big volume of snow and speed, and the highway is right there. It has hit the closed road. This is a large avalanche. This is just another one of our tools and safety protocols that we use to mitigate avalanches. It's the most effective way to trigger avalanches. I mean, time will heal all wounds, but we can't afford that length of road closure. So we'll go in just before the natural cycle, whether it be snowfall or wind that would trigger the avalanche. We'll be ahead of that, and we'll use explosives to manipulate that and to kind of speed that process up. I'm from the, kind of the school of hard knocks, time spent out in the field, in the trenches. It's a rewarding career. It allows me to stay outside, and battling Mother Nature is always interesting, and she always holds the upper hand. Well, we train to a very high standard, and we allow ourselves big margins of safety through traffic control, PPE. We use blast shields, and our program here at CDOT is mentorship based. So we're going to take the experience of guys that have been doing this for 10, 20, 30 years and use that to bring up the new generation and how to handle and transport and use these explosives safely.
Hello everybody, my name is Mark Ganster from Austin Powder in Europe. I'm the manager of blasting technology with Austin here in Europe. Austin Powder manufactures explosives on a worldwide basis. It's a US-based company and produces not only avalanche explosives, it also produces explosives for mining, for civil blasting, and for many other applications like seismic. And my today's role in the avalanche control work is supporting customers, guaranteeing that the product is okay, that they get the right product for their use. And also I'm part of the research and development team within Austin Europe's team, where we work on getting better explosives for avalanche control all the time. In most cases we go out when we have intense snowfall or snowfall zones, areas, when the temperature changes pretty much. So you have warm conditions, then you have following that a cold condition and following a warm again. So that means the snow crystals are changing its condition. So they look different and the snow is more intended to move on different kind of snow crystals. And we go out for avalanche blasting if we have strong winds, when we have couple days, following days with strong wind conditions. So that means that the snow has displacements. So the snow is moving from a safe zone through the wind to the backside of the wind side and is depositing there. So then we need to go out and blast for avalanches. For sure in the mountains, it's not in the flatlands. And on this picture we see on the lower left is ski slope. We see some backcountry ski area in the middle of the pictures, and for the enthusiasts we see on the right top of the picture, very far away, a lot of good powder snow backcountry skiing resorts. So we need to secure those ski resorts for all the winter sportsmen and women. So that is the job we do with avalanche explosives. We have to secure also urban areas, small cities, towns in the mountains. So our mountains are pretty much full of cities and towns. We have to secure the streets to those cities to keep the supply chain open, and we have to secure the ski slopes where tourists and tourism is having a very important impact on our economy. So Austria as well as Switzerland and France are very much dependent on tourism. The picture on the lower right you see is one of our passes here in Austria. It's the Pürn Pass, and this Pürn Pass is not very high leveled. It's just about 3,000 feet above sea level, but it's one of those access roads to the mountains, and you see the mountain in the back is about 2,500 meters, which is about 7,000 feet. And we have to secure those access roads and also the area for the ski tourism. Some examples of use, how do we do avalanche blasting here? Positioning stick charges, and those stick charges have a weight of 5 to 10 pounds or 2.5 to 5 kilos. And the guy needs to go into the safety zone, so into the risk zone, where the snow masses need to be blasted. And you see there is a rope guiding to the guy, and the guy is secured by a second guy. So in case of initiating the avalanche before the explosives goes off, the guy could be secured by his friend. This blasting cable car is designed and built only to transport explosives charges into an area of avalanche risk zones. And the avalanche blaster here is positioning a charge of 4 cartridges, which is about 20 pounds or 10 kilos, on this blasting cable car. Then you see initiated it is by safety fuse. The safety fuse has a burning rate of about 2 minutes per meter, and you see here is approximately 2.5 to 3 meter safety fuse, which means a burning time of about 5 to 6 minutes. And the guy is initiating the safety fuse. The safety fuse then is initiating the plane detonator, which is in the cartridges. And once the safety fuse is initiated, the guy moves the explosives up the hill with the blasting cable car. And on this video you see very early in the morning the initiation on the top of the mountain here of these snow masses with an explosives charge of 10 kilos. The avalanche is forming out, is moving very fast down the mountain and reaching out to the ski lift and to the ski resort. So you see, avalanche blasting is a job for the morning, it's not for the afternoon, so you need to go earlier to be able to secure the ski resorts before the tourists can start with the sports. Another possibility is blasting from the helicopter. And you see here a helicopter from the Austrian Army. It's not standard that the Austrian Army is doing avalanche blasting in the Austrian Alps. But 2 years ago, we had a very, very heavy snowfall over 4 days all over Austria. And all the helicopter capacities Austria has on a civil side was completely overbooked. So we had to contact the army, and the military was helping out with their helicopter fleet, and also they have a couple of avalanche blasters, of certified avalanche blasters in the Austrian army, because preparing a charge during a helicopter flight is very difficult. Sometimes you have strong winds, it's not easy to prepare explosive charges in a helicopter during the flight. So it's all prepared before, and just then you see here the yellow rope is again the safety fuse, and the initiation of helicopter charges is also done by safety fuse and plane detonators. So the charge is initiated and thrown out from the helicopter. What the helicopter then does is he's throwing out, or what the helicopter personnel is doing is throwing out the explosives charge in the mountains, taking a round turn with the helicopter and having a look on the impact of the explosives. So they are tracing where is the explosives being detonated, is it detonated, what was the result of the blast. Was the result achieved that snow masses could be moved, or does he need to fly a second time? This could also happen, that you need 2, 3, 4 attempts to get the snow mass moving. And another possibility is avalanche control masts, that you use avalanche control masts in your mountain. Sure, you have to position them in the critical area, in the area where you can see avalanche possibilities, or where you see the need to secure these avalanche possibilities. And you have this magazine area, so on the top of those masts is a magazine placed, and this magazine could be remotely controlled and initiated. It's stationary masts, and you can have 12 shots per mast in this mast. A plastic shell with the explosives positioned inside. You see here is again safety fuse, plane detonator positioned in the explosives. And on top of the explosives you have some kind of a rope positioned, where this rope is then holding, once the remote control operator is initiating a charge, the charge is falling down on this rope. When the charge is leaving this magazine area, the safety fuse is initiated, so it's burning. It falls down, it hangs on the slope or on this rope above the slope, and then detonates and initiates above the snow level this possible avalanche. What kind of tools do we need for avalanche blasting? So we have on the one hand side the safety fuse. I talked a little bit about that during the presentation. And the safety fuse is burning with a burn rate of about 2 minutes per meter. We use the safety fuse together with blasting caps or plane detonators. So we crimp with a crimping tool those plane detonators onto the safety fuse. And the safety fuse could be black or could be yellow, depends on the producer. And on the other end of the safety fuse, we use a firing pin initiator. So that means you're pulling out here a pin, and then there's a mechanism. And then the safety fuse starts to burn until this flame inside reaches the plane detonator. The plane detonator is then initiated and is initiating the explosives charge at the end of the story. I think the most important thing is that you are willing to move out. It doesn't matter what kind of weather is out there. So in most cases, avalanche blasting happens when the weather is not sunny and not warm. It's more windy and ugly weather. So you need to be an enthusiast on outdoor activities, you need to be interested in explosives, you need to be interested in avalanche control, in the whole topic of avalanches. And then the job could be really very, very highly interesting and could be fun also.
Well, that was a really interesting segment about using explosives in high mountain passes to make avalanches safer. Now we're moving on to the question and answer session, which has been moderated by Travis David-Saver, an ISEE board member and Emerging Professionals chairperson.
All right. Well, thanks again, Alistair. Without our sponsors, we would not have been able to bring you this 10-part, 5-night free webinar series to you here in the month of March. Now let's talk with our panelists, Brian, who's in Colorado, and Mark, who's in Austria, which really, really early in the morning, who are here and ready to answer your questions. Please send any questions that you have via the question and answer box, and while doing so, let us know where you're from, and if the question is for a specific panelist, let us know which one. Our first question this evening comes from Jake and Abby and Adam, who are in Illinois, and how many charges can you fit in a single helicopter?
Well, Travis, that would depend on the type of helicopter you have available to you, the altitude, temperature, how much fuel the helicopter needs to carry to support, just call it one cycle of that mission, and the weight of the people in the helicopter and the charges. So I'd say on average with what we do here in Colorado in our high elevations, we're somewhere around 7 to 10 shots at that 25, 30 pound is our kind of standard procedure.
Mark, does it differ at all in Europe?
It's pretty much the same. So I think it also depends on the space in the helicopter. So how much cartridges you can fly on the total weight, on outside conditions, and on this kind of stuff. Yeah, it's the same.
How long does one of these avalanche control missions take by a helicopter? What's a typical timeline?
For us in Colorado, we have zones kind of spread out over a large geographic area, but I would say, we can cover like the I-70 corridor in about 25 to 30 minutes.
Pretty fast.
Yes, very fast.
All right, our next question is for Brian. It's coming from Kathy in New Mexico. With regards to avalanche control, has climate change affected snow load and snow conditions in avalanche work?
That's a great question, and I would say absolutely. With the weather patterns, even you take the short amount of time in space that I've been doing this, and we're seeing winter start a little later, last a little longer. We're seeing temperatures rise, and in certain places, rain in higher elevations, which further complicates avalanche conditions in these typically drier climates. So yeah, absolutely.
How about Europe, Mark?
I would say the same, yeah, because we have changing weather conditions, more and more changing weather conditions. So we don't have those stable cold conditions like we had in the past. So most times around Christmas, it's warm, like 15 degrees C, which is about 60 Fahrenheit or so. And a week later, it's getting cold again. So in this changing parameters is not a very good thing for stable conditions in the snowmass.
All right. Our next question is for Mark, and it comes from Richard in New Caledonia in the South Pacific. Has avalanche control technology been used to possibly trigger landslides?
No, not really, because you just have your charge is above the or slightly in your snowmass or avalanche area, so you don't get the energy down. And to trigger landslides, it's a different technology. You need to have water saturated conditions where you increase the water pressure inside your rock or sand. So we just saw triggering secondary avalanches by shooting a primary avalanche, and this mostly happens if you have these conditions in the mountains, like opposite steep slopes.
Okay. The next question is probably another question here from Mark, but I think, Brian, you might be able to answer it as well. And it comes from Alistair in Australia. I wonder who that might be. Do you have any problems with sensitivity of explosives in the low temperatures you are working in?
Depends on the explosives you're using. So we use combinations here in Europe, either of emulsion technology, emulsion explosives, or ANFO-based explosives. And in our research and development team, we're going to test temperature cycles on the explosives. We are safe until minus 30 degrees Celsius. So don't ask me what that is in Fahrenheit, but it's pretty low. Yeah.
So Brian, I mean, you've got all these not magazines, but mast systems or rack systems that the explosives are out there in many weather cycles. Are you seeing any difference in performance?
No. One of the technologies, the Avalanche Guard system that we use, that's a cast booster, and that's good up to cold temperatures that are way colder than you would see the type of conditions to initiate an avalanche. So quite stable and quite effective in those temperatures. The VSIN product, that's new to us this year, and that does use an emulsion product, but once again, minus 30 degrees, that's not a temperature where you typically see avalanche conditions. It's a cold and clear, storm's over.
All right, next question is another one for Brian, and it comes from Rachel in Ohio. Are there significant differences in how ski areas perform avalanche control versus that of a public agency such as the DOT?
Yeah, absolutely. So ski areas, they're looking to protect the customer and some infrastructure. So they're going to, they have the ability to get explosives delivered on that slope, and then they'll get their ski patrollers out on that slope and start cutting up and disturbing those weak layers. And as the people ski it in, it creates conditions where they can deal with much smaller avalanches day to day. And so they're going to do more frequent mitigation. And we attempt to do a similar thing in the DOT world, although we're not benefiting from any sort of skier compaction over the course of the season. But you take a corridor like I-70, where the Eisenhower Johnson Memorial Tunnel is in 3,000 cars an hour. We can't afford a long duration closure for cleanup is generally what takes the most amount of time. But we can do the mitigation relatively short with inside a half an hour, but you start putting some large avalanche debris on the roadway, that's where your time is consumed, and the closure will take a long time.
All right, thanks, Brian. Our next question is for Mark, and it comes from Tanya in Florida. With so many mountains or so many towns in the mountains, who takes the lead for avalanche control efforts across Europe?
That's a good question, and it's locally managed by local teams of experts in the avalanche technology. So every town in the mountains has their expert team, which consists of about 6 to 8 people. They come together. They have helicopter flights into the mountains to evaluate the snow conditions. They have a look on temperatures all the day. They have a look on weather conditions, wind, and then they come together and decide what to do. Either they have to close roads, or either they have to fly helicopter avalanche blasts. So it's locally managed from town to town. Yeah.
Okay. Our next question is, I guess, for both of you, and it comes from Timothy. Are drones being used at all in avalanche control efforts?
There's been some research, probably over the last, 15 years or so, we're try to, makes a lot of sense, but nothing as of yet that's anywhere near production that I'm aware
of. We just started recently last year with deploying some explosives through drones, and in recent right now we are more using drones to evaluate the real conditions, so you can fly in without having a risk you don't deploy people, you don't bring somebody up. But we're just starting also using explosives with drones, and I think that's absolutely the future. That's you're more flexible, you have more options, so you're not limited to helicopters. So I think that's the future for the mountains. Yeah.
All right. Our next question comes from David, and it's again another question for both of you. What types of explosives are used in avalanche control?
Well, here, in the Intermountain West, Penalite, cast booster, that's what you're going to see at most ski resorts that are these hand-thrown charges. And then the Avalauncher is also a Penalite cast booster. You have your howitzer rounds, which is a mix of RDX and TNT. And then kind of the way we're going are these gas mix systems. Is quite popular at the moment.
Yeah, we don't use gas boosters here in Europe, so we just go for emulsion products, emulsion explosives, and ammonium nitrate based explosives. It's not pure ANFO, it's just sensitized a little bit differently and includes also aluminum. So we're going a slightly different way than you guys in the US, but yeah, that's it.
All right. This is a question again for both of you, and it comes from Lee. Do different avalanche types require different charge weights and placements?
Absolutely. Yeah, so there's many different types of avalanche problems. And so depending on that problem, if you have a deep slab problem, which we've had a lot this year, we're going to use bigger charges. And generally, we're looking for the thin spot in the snowpack to initiate that weak, or to be able to affect that weak layer easier, and then initiate a propagation.
All right. Our next question here is a question from John, and it's another one for Brian. And maybe, Mark, this applies to Europe as well, but is anyone using RECO tags to locate misfires?
The only place we use the RECO tags is on our Avalanche rounds. And so, yeah, we do. That would help us with, if we did have a DOD, then we can go in with our RECO device and help locate it that way. But that's the only explosive that we're putting on this time.
Mark, is that technology being used in Europe?
No, we're using more standard reporting. So people have to report if the cartridge or the explosives has fired, and then they have to make a note on the map where, if there is a misfire, where it has happened, so that they can get it in the springtime. So GPS is difficult in our conditions, because sometimes you don't have the required signal.
Okay. This is a question for both of you, and I'll read it here. It says, "Hi, thanks for your explanation. It's been very interesting. This is Jessica from Mexico. How do you manage to calculate the type of explosives to use in such low temperatures, and what factors do you take into account?"
Our stuff is pretty standardized. I mean, if it's a hand charge, it's typically be a 2 or 5 pounder, and it's just based on experience. And then, in the highway world, we're looking for the most effective charge, and being as efficient as we can with a road closure. So bigger is better.
Bigger is better. All right. Any differences that you see in Europe, Mark?
There is literature out there where you can find formulas for calculating charges, but as Brian said, bigger is better. So you always go on the safe side. You're over dimensioning your avalanche charge, not like in rock blasting, where over dimensioning is not so funny. So yeah, there's literature outside, and you can have a look on that. So I'm happy to share this literature if somebody wants to know.
All right. Our next question has actually come in from multiple people, and it's for both of you. How do you recommend someone get started in avalanche control blasting?
Well, I think these days, there's several paths to getting into this work. Historically it was you get a job at a ski area that does a lot of mitigation work and kind of work your way up through the ranks and be out in the field. These days there's some other avenues where there's actually snow science degrees that you can achieve a meteorology degree. There's a lot of engineers, some kind of those technical degrees, but you're still going to have to get your time in the field. So generally time spent on a ski patrol as some combination of.
Yeah, it's the same here in Europe. So you need to be interested in, you need to be an outside enthusiast, you need to be connected to the mountain sports, skiing, whatever. So the most important thing, like Brian mentioned also, is experience. Be out there in the mountains for years, use it in your spare time, in your free time as a hobby. So all that connects together, and getting a broad understanding of the risks of avalanches and snow and conditions. So and education is a big topic here. Yeah, you have to be also in courses, learn about it, and combine your personal experience with technology trained in the classroom. Yeah.
All right. Well, I'll be honest, we have a mountain of questions coming in. So I have to agree with Evan here, who starts out his question with a statement, "Great show tonight." And I can't agree with him more. But Evan's asking, what safety measures do each of you take to prevent misfires? And have you ever had to clear a misfire?
Yeah, it's, we do everything in our power to avoid the misfire, but it is, something that does happen. We try to keep it less than 1% of the time. And it's generally some sort of, user error is what caused the misfire. And yeah, it's not the most favorite part of the job. You have a dud, that's an automatic hour stand down, and that 60 minutes with the road closure can take an awfully long time, longest 60 minutes of your day for sure. And so depending upon what that error was, it dictates how we deal with it.
All right.
Yeah.
Go ahead, Mark.
It's the same here. So it's always difficult to clear up a misfire in a danger zone. So you cannot walk down and get to the explosives charge and just take it with you and bring it back, and that's not possible. So that's a job for the springtime or summertime, where you go back to your records and try to find your charges, and then just eliminate those kind of misfires. So, but as Brian said, yeah, it's less than 1% at least. Yeah, and it's human error in most cases.
Well, I think that
the other tricky thing.
Okay.
Oh, I'm sorry. The other tricky thing is if you had a misfire, well, you had a reason for shooting that slope, so you probably still want to shoot the slope, and so it could get a little stressful in those moments.
Well, I think, you answered a question that came in from one of our anonymous viewers tonight. Is there any quality control, quality assurance, or inspections done before or after avalanche control? And I think you both just indicated that's really the case. Is there's a very stringent tracking and control process, and a strong effort to retrieve any issues that you might have had with misfires along the way.
Absolutely.
Our next question is for Brian. It's coming from Molly in Kentucky. What training is provided to ski patrollers and DOT technicians to perform avalanche control?
Well, so as you're new to the industry, we start with the basics: terrain recognition, weather factors, snowpack factors that produce an avalanche, rescue skills, and then the mentorship-based training takes over, and you're just the leash is getting a little bit longer as the longer you've been there. We are, for the DOT, our training is approved by our oversight, the Division of Oil and Public Safety. Our training for the howitzers is approved by the military, the United States Army, and there's a job map to this. So, your first avalanche control mission on a ski patrol, maybe they'll initiate the explosive and then you get to throw it, and then the next time, just slowly work your way up through this, and
and in each position, depending upon what sort of system you're using. So if you're an avalancher, you'll oversee the mission, or you'll observe the mission, and then the next time they'll let you help build the rounds, and then the next time you get to help load the rounds, and there's a progression to this. And so it's at CDOT, it's very structured, X amount of missions before you can move on to the next step.
Our next question is for Mark, and it comes from Gene, who's in Minnesota. With a lot of Avalanche technology originating in Europe, what do you see as the next big evolutionary step for Avalanche control?
We mentioned that before, and I think it's the drones. It's the drone technology. So technology in drone capacities, of size of drones, of being able to fly more weight on civil drones. I think that's going to be the future for being more flexible, for having more flights per day. Every single operator could fly a drone, so you don't need necessarily a helicopter pilot, or you don't need ski patrol troopers walking into a danger zone. So there is a couple factors influencing or impacting this drone technology to be further developed for avalanche control, and this is safety for the people. This is flexibility in supplying charges to the danger zones and much more. So yeah, drone technology.
All right. Our next question is from Scott. And Scott's asking, how do we prevent theft or explosives, theft of explosives in the automatic systems such as the racks?
So the racks, they're considered magazines, and so they're very secure. They're locked multiple times, and they're generally, we implement some measures, that they're very high off the ground, and we'll store the ladder in a secure location, locked. And so it would take an incredible effort at 12,000 feet to manipulate one of these magazines to steal or whatever someone would want to do with them.
And I think in addition to that, they're in really hard to get to locations.
Yeah, absolutely. Yeah, like I said, most of our stuff is above 12,000 feet, so it's no small effort to get there to begin with. And a lot of these things are, how we get the supplies there is via helicopter, because they're so different.
All right, our next question is another one for Brian, and it comes from Nancy in Alaska. And I think Nancy's looking for just some general idea. This concept of avalanche control is new to a lot of people that handle or see or use explosives. Can you give us a feel for how fast the snowpack is moving, and what types and what areas an avalanche like these that you're controlling affect?
I think on general, if you have, a large avalanche, you're anywhere in that 80 to 100 miles an hour. Depending upon its vertical fall, but say somewhere around 1,500 vertical feet, 2,000 vertical feet, that thing is moving, absolutely. And it's one of the most awesome forms of nature doing its thing that you can see, I think.
Right, we have an anonymous question here that's coming in from the audience for both of you. Can you describe a situation where the results of the planned controlled avalanche mitigation didn't go as planned?
Yeah, that happens, sure. So if the snow mass is much larger than expected, also if you are probably triggering a second avalanche by the explosion of your explosives being intended just to move one avalanche. So the safety zone is a critical part which you need to estimate, and it's always an estimation. So there's a lot of experience coming into this estimation from people who are familiar to this area where the avalanche is triggered or blasted. But there is a risk of initiating more than planned. So yeah, it happens that roads are closed in, it happens that damage appears, but it's always important that you clean up or that you just clean the safety zone. No people should be involved. So that's the highest priority. Don't get somebody involved in this.
All right, we just have a couple minutes left, and our next question here is for Mark, and it's coming from Paula in Colorado. What other industries or explosives users still use safety fuse?
It's mostly used in the natural stone industry, where you use black powder still to produce large boulders, and they are then cut it into blades for, kitchen tables and floor blades. So safety fuse is just used still with black powder charges in the stone industry, but nothing more. The main use is avalanches.
Okay. I think we have time for 2 quick questions here. And this question is from Bobby and Rick in Jackson Hole. And the question's for Mark. Why don't you use cast boosters in Europe?
Good question. So that comes from the past. So we don't like black signs on the snow from the TNT detonating. So that's one of the downsides of the cast boosters. The good thing is they are super reliable. You have high energy, but you see the black signs of a cast booster detonated, and that's what people don't like here. And availability of cast boosters in Europe, that's the other part. So we don't have it so common here in Europe than you have it in the US.
Okay. Our final questions for both of you, and it comes from Molly in Louisville, and I'll kind of summarize this. Do either of you have a quick or good point or a story to share about avalanche prevention, and maybe share a best practice that you can give to our audience?
Yeah, it's each situation is very dynamic, and we have guidelines and thresholds based on years of experience in science, but Mother Nature always holds the upper hand, and so keeping your head on a swivel and open to being surprised, because it does and will happen.
Yeah, I think one of the most challenges is supplying good hand charges. So if you have these hand thrown charges into an area, you just have one try to deploy the charge. You don't get it back up and throw it again and get it back up and throw it again. So that's a no-go. So I think that's the most challenge. And there is, I think you could tell a lot of stories how charges have been thrown and did not detonate where they should detonate. So yeah.
All right. Well, I really want to thank all of you online for joining us tonight, this morning, today, whatever time it happens to be in your time zone. And I really appreciate the great discussion. And I want to really extend a sincere thank you to both you, Brian and Mark, for being here and helping share your knowledge and thoughts on how we're using explosives for avalanche control. Now, again, we really appreciate everyone being here. Now I really want to go back to Alistair, who's going to share some news on some upcoming events that we have in our industry. Thanks, everyone.
Thanks, everybody. Thanks, Travis.
Thanks all.
So thanks, Travis, and thank you for watching this episode of the ISEE Explosives Everyday series. Explosives are the ultimate power tool that help mine the minerals and materials that are used in creating many of the products and roadways we use each and every day. They help keep our towns and cities safe from avalanches. They are used to shape and improve the environment, and also military and demolition applications. And they're in some of our favourite TV shows, movies, sporting events and concerts. Our job as professionals in the explosive industry and at the ISEE is to ensure explosives continue to be handled and applied in the safest way possible, and to continue to provide the resources and tools needed to help advance the science and art of explosive engineering. If you're interested in finding out more about the International Society of Explosive Engineers, please go to our website, isee.org. You'll find information about membership, our chapters around the world, and other useful links, including a calendar of upcoming events, as well as conferences and meetings in our industry. Another great resource is the World of Explosives, where you can find information on using explosives safely, the most frequently asked questions from homeowners about blasting, how blast vibrations affect structures, and all the planning that goes into each blast. It's also home to Explosives the Power Tool. This is a video series covering the history of explosives and the technical advancements that have been made possible because of it. To check it out, visit explosives.org. So now a special thank you to this episode's sponsors, LDE Global, Dyno Nobel, OPIT Blast, Austin Powder and the European Federation of Explosive Engineers. Before we go, here's a short message from OPIT Blast.
5, 4, 3, 2, 1. From now on, your blast designs will be perfect. OPIT Blast presents the best blast design software simulator. Securely store all your projects created in the OPIT Blast in the OPIT Cloud, allowing staff to access all the information using the OPIT app, OPIT Dev. The best value for money on the world market. The definitive solution for measuring borehole deviations in quarries and mines. Efficient for 360-degree measurements. OPIT Blast. With us, it's possible.
I think the courses here are very informative for both the management as well as shot firers. Atmosphere is fantastic as always at ISEE, and that is why I have come many times to the conference.
So that's it for this episode of Explosives Every Day. If you like this content, be sure to like and subscribe to our YouTube, Facebook and LinkedIn pages to stay up to date with all the latest ISEE happenings. And be sure to check out all 10 of our episodes highlighting the different ways explosives are used around the world every day. On behalf of the ISEE, thanks for watching and we'll see you next time.